Good morning, students. Today, the next chapter we are going to continue straight lines. To see the straight lines, we already know or we have been learned about analytical geometry. That is nothing but coordinate geometry. First, we recall some of the formulas what we have learned. In Cartesian coordinate system, it is of x-axis and y-axis. Consider two lines or straight lines which are perpendicular to each other at a point of intersection called origin. This line is called horizontal line. This line is called vertical line. At any point if you are taking here p x comma y, this should be satisfying the distances from x dash o x or x o x dash or y o y dash or y dash o y, like this. We have been named as O M P N. Therefore, any point p x comma y, example I have taken in the first coordinate. Any point p x comma y is the satisfying the distances from x o x dash to y o y dash is called, we have taken as OMPN, rectangular Cartesian coordinate system. This is the coordinate system which we are having two axes. It is also called as two-dimensional geometry because we will have two axes. After this, we have learned the coordinate system. On x-axis, if you take a point, this will be x comma 0. That means y will be 0. If you are taking any point on y-axis, x will be 0. This will take as 0 comma 1. And we all know that if you move the anti-clockwise, here we take it as x greater than 0, y greater than 0. Here we take x less than 0, y greater than 0. Here we will take x less than 0, y less than 0. Here we will take x greater than 0, y less than 0. The point of intersection is O. These we have learned, and we also have been learned just we are recalling the formulas which are used in the analytical geometry, and we will move to the topic straight lines. And here next we have learned distance between two points. In the coordinate system, distance between 2 points P and Q. Let P x1 comma y1 and Q x2 comma y2 be two coordinates are two points line joining PQ. Is PQ equal to what you have derived there? Root over. If P we have taken x1 comma y1, Q x2 comma y2, we have derived x2 minus x1 whole square plus y2 minus y1 whole square. And next, one more formula we have derived. This is distance between 2 points. These all we have learned in the 10th standard that we are recalling. Next, we have been done section formulae. Section formulae is nothing but a point P which divides the line joining points AB in the ratio m is to n. A point P x comma y divides the line segment or line joining points A x1 comma y1 B x2 comma y2 is P equals to what you are getting m x2 plus n x1 by m plus n m y2 plus n y1 divided by m plus n. We have taken this point as x1 comma y1, this point we have taken as x2 comma y2, and P we have taken as x comma y divided in the ratio m is to, like this. If you want, this is the P line segment AB divides in the ratio m is to n. This is section formula. And at last, we have seen area of a triangle. If ABC is a triangle with vertices A, x1 comma y1, B, x2 comma y2, and C, x3 comma y3. 0 x-axis, y-axis, A, B, C. This formula we derived, area of a triangle equals to half modulus of x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2 modulus. Why we are taking modulus means area should not get negative. If you got the negative value also, we will make it into positive. That is area of a triangle. This what we have learned in the previous classes, that is called elliptical geometry or coordinate geometry. We have learned distance between 2 points, how to represent the points, and area of a triangle section formula. Now we will move to the topic as in all these things we are using the lines, and we are telling that we should consider 2 lines. Yes or no? Inside the mathematics now we are seeing straight lines. Before going to straight line, we have seen what is meant by coordinate geometry, and here straight line means there are 2 definitions. One is a line which has no end points. Definition, simple definition, a line which has no end points is called a straight line. It is a general definition, and if you want exact definition mathematically, locus of a point P moves in such a condition that that distance is fixed from 2 points A and B is called a straight line. Therefore, this theoretically we have written. What is the diagram? We will see that. What the condition here there? I will tell what is meant by locus. What is meant by locus we'll discuss there. Before we'll see what is meant by straight line. We are having is fixed from 2 points A and B. That means which is fixed there? Point P, and here PA equals to PB. The locus of a point P is fixed to 2 points A and B. Then we are getting a line. There are no end points. This is called straight line, or we can say it as it is perpendicular to line AB. Therefore, we can, because it cuts the line, we can call it as perpendicular bisector also. It is called a straight line. It is named as perpendicular bisector. Now, students, you will get the doubt what is meant by locus. Now, until now, what we have learned? Coordinate geometry in coordinate system, how to represent the points, first coordinate, second coordinate, third coordinate, fourth coordinate, and we record the distance between 2 points, area of a triangle, and section formula. And now we have been seen to the definition of the straight line. The definition of the straight line is nothing but locus of a point P moves in such a condition that condition is what? Fixed, its distance is fixed to 2 points. Is called a straight line. And here we have to know what is meant by locus. When we are knowing locus is one chapter there, now it has been deleted. We see that what is meant by locus. Simple definition. Straight line means what we can say? It is nothing but a line which has no end points. If a students are getting doubt, a line which has 2 end points is called what is the line segment? Yes or no? Which has no end points is called straight line. That having that line we name it as what? Perpendicular bisector. That is the concept of the straight line. And in that we have been using locus. The locus definition is when a variable p x comma y moves under a certain condition that the path traced by the point is called locus. Example, what we can say? Example, nothing but we can say straight line, because when a variable p x comma y moves under a certain condition that the path traced by the point is called locus. And here the path is what there? Fixed point p. We are having condition is what there? Fixed distance to A and B. That means condition here from locus point P, distance from the point A is equal to locus point P to the distance of B. PA equal to B. The traced path of the locus of the point P to the fixed points AB is called a straight line. The P is called what there here? P comma x comma y is called a any locus point, any locus point. And the condition should be that the path traced by the point is called locus. Now we have learned what is meant by locus. A locus example is straight line. Straight line definition is it is a path having getting a perpendicular bisector with fixed points A and B is called a straight line, or simply a line which has no end points is called a straight line. Now we move to the concept of inclination. Now we will move to the concept of inclination. Inclination means what? The angle theta, 0 degrees less than or equal to theta less than 180 degrees made by x-axis measured in anti-clockwise orientation means rotation, orientation from the positive direction of x-axis is called an inclination. What is the geometrical representation of this? We are having two-dimensional geometry. We are having a inclined line in the positive direction of the x-axis, rotation anti-clockwise. This theta will take it as inclination. And now slope. After deriving the inclination is what? Then the angle theta rotating 0 to 180 made by x-axis measured in anti-clockwise. This is rotation of orientation from the positive direction of x-axis is called an inclination. If theta is called inclination of a non-vertical line, then tan theta is called slope of a line. If theta is called the inclination of a non-vertical line, then tan theta is called slope of a line, because it is slant there. It is slant. This theta will take it as tan theta. Now children will get doubt, why start taking only tan theta? Because we are having 6 trigonometric functions, we can take any of the function. Why we are deriving only tan theta? Okay. Now once we recall that, what we have learned, what is meant by straight line. Coordinate geometry already you know. We have learned what is meant by straight line. Straight line is nothing but a line which has no end points or locus of a point P x comma y moves in such a condition, its distance is always equal to a two fixed points A and B is called a straight line. And after the straight line getting, we are learning about what is meant by inclination. Inclination, up to here we have to see. Inclination. Inclination means an inclined line. It is not horizontal, not vertical. It is non-vertical line. This line with the positive direction of the x-axis, rotation is anti-clockwise, is called inclination. If theta we are taking as inclination, this non-vertical line with the tan theta, we call it as slope of a line. Slope of a line. Why tan we are taking, will come to know. Now slope of a line means tan theta, and it is denoted by m. Slope is denoted by what there? Small m. It is denoted by small m, where m equals to where m equals to, we are taking what there? Tan theta. The slope of a line is m equals to tan theta, where theta is the inclination. And now we have to discuss why we are taking only tan theta. Now we will discuss. No? This is clear up here? Yes. We have learned what is meant by straight line, inclination, slope of a line. Now we are seeing why slope of a line we are taking only tan. Now what is our discussion? Why we are taking slope m equals to tan theta. Yes or no? You see the diagram in the two-dimensional geometry. It is x-axis, it is y-axis. If initially on x-axis you see, whenever we see that angle we should take by the y coordinate by x coordinate in the right angle triangle. Therefore, if you see this, initial line is 0, that means initially the angle will be 0 there. Yes or no? It is on x-axis. Initially angle will be 0 degrees. We know that theta is 0 degrees means we can find out the slope. Therefore, slope m equals to tan 0 degrees, what error in there? 0. Initially we are getting 0 there. And angle of y-axis not defined. Yes or no? We can't define the angle of the y-axis. It is not defined. If you take here, it is perpendicular means we will take 90 there. Therefore, if theta is 90 degrees, m equals to tan 90 degrees, what we are getting? Infinity. That means it is not defined. Therefore, for tan theta only, we will get initial angle as 0 and y-axis slope is not defined. Remaining whatever the function you will take, this will not define there. For that purpose, slope of a line with angle, always we will take it as slope of a line when we know theta. We have to take formula as m equal to tan theta. Representation of the slope we have taken as m. And with this we can derive. With this we derived as what there? Slope of x-axis we derived. Slope of x-axis. M equals to what we are getting? 0. Is that my initial? Next, we derived slope of y-axis. M equals to what there? Not defined. Therefore, here we are getting that otherwise we can take infinity. Not defined means we can take infinity. Slope of x-axis, slope of y-axis we got. From y we are taking m equals to tan theta. This is the concept of slope of a line. Next, we are having different theorems to derive the formulas. On this one example, we'll see. On this one example. Now, what the formula we derived there? Slope of a line is m equals to tan theta when we know the inclination. When we know the inclination. Therefore, examples. One example we'll take. Example. Find the slope of the line making inclination inclination of 60 degrees with positive direction of x-axis. Solution. Inclination means what we discussed there? Theta. That means here given inclination theta equal to how much there? 60 degrees. What they want? Slope. When you know the angle, slope of a inclined line or non-vertical line, m equals to what formula we are having? Tan theta. Therefore, m equals to theta plus what you have to substitute? 60 degrees. Therefore, m equals to we are getting what amount? Root 3. This is the slope of a line when we are knowing the angle with the positive direction of x-axis. Now, next concept. Next concept onwards, we'll see like a theorems there. We'll make it as theorem 1. The slope of a non-vertical means it is not horizontal, not vertical. Non-vertical line passing through the points x1, y1 and x2, y2 is slope is represented as small m. y2 minus y1 by x2 minus x1. This is the formula. Finding the, until now we have learned slope of a line when we know angle. Slope of a non-vertical line when we are having 2 points. What is the formula? M equals to y2 minus y1 by x2 minus x1. These proofs are not important. For our concept wise, we are learning the things. Exam point of view, they will not ask these theorem proofs. Which are important, I will tell them. Proof. Consider a line L1. Select the diagram. We have taken one non-vertical line with what we are having among? We are having passing through how many points? 2 points. Passing through inclination theta. On this we are having how many points? 2 points. This is, we name it as A, x1 comma y1. Next point we will name it as B, x2 comma b2. Now with this, what we have, whenever the point is mentioned on the coordinate axis, what we have learned, we have to make the satisfying the distances from x-axis and y. That means it's A, and this is y1, and this is x1. From this also, if you see, this will give this one. This total is y2. This is x2. Now this is A. We extend this one to C. Okay, ma? Now what we have done? Consider line L1 with inclination theta and passing through points A, x1 y1, B, x2 y2. Slope of a line, we know that slope of a line L1 equals to m equals to what we are having, tan theta. Here this is perpendicular. Here theta, this also theta. We extended AC. Yes or no? We extended AC is parallel to x-axis. Now inclination slope of a line is m equal to tan theta. By definition, we can write tan theta equals, you see here, angle equals to opposite side by adjacent side. Therefore, BC divided by AC. If you see the diagram, this is y1, total we are having y2. I want only this BC. If you want this BC means total minus what we are having. Therefore, BC will be y2 minus y1. And I want only AC. From here to here we are having x2. And here we are having x1. Therefore, x2 minus x1 will get this value. Therefore, this will give x2 minus x1. Slope we representing in the form of m. Therefore, we derive that slope of a line when it is passing through 2 points. Slope is y2 minus y1 by x2 minus x1. Otherwise, we can remember in the form of difference of y coordinates by difference of x coordinates. Slope, when you are knowing 2 points, to find out the slope of a line, difference of y coordinates by difference of x coordinates. How we are getting means, we consider a line L1 with inclination theta passing through the points A, B. Okay, ma? Therefore, this AC we extended parallel to which axis there? X-axis. Therefore, x1, this is x1, this is y1, this is x2, this is y2. We have seen that representation of the points O, M, P, N starting here. Now, this total is y2, this is y1. I require only tan theta is BC divided by AC. BC part. I want only this part means total part minus this one. Y2 minus y1. And when you want AC, total part is x2 minus remaining part x1. This is slope of a line. Now we'll see one example on slope of a line when we know 2 points. When we know 2 points. Example, find the slope of a line. Find the slope of a line passing through the points. Passing through the points 3, -2 and -1, 4. Here we are knowing how many points they given 2 points, and they want slope of that line. It is passing through 2 points. It is nothing but what the diagram we have been seeing. Inclination theta. Let A be point. Here we are having 3, -2. Here we are having -1, 4. This formula we have been derived. Solution. Given points B, A 3, -2, B -1, 4. This will take it as x1, y1. This will take it as x2, y2. Slope of a line passing through how many points? 2 points. Passing through 2 points, formula m equals to y2 minus y1 by x2 minus x1. Now this equals to, what is y2 we are having here? In the y2 place 4. y1 place -2. Then x2 -1 minus half. x1 3. Therefore this will give minus of minus plus 2. -1 minus 3 -1. That means we will get 6 by -4. Therefore m equals to, we are getting -6 by 4. This can be cancelled by 2 tables. 2 3 are 2 2 -3 by 2. Therefore we can find out slope of a line when we are knowing 2 points. And before we have learned slope of a line when we are knowing the angle or inclination with the positive direction of x-axis. Now, another theorem. Theorem 2. If two lines are parallel, then their slopes are equal. When two lines are parallel, then their slopes are equal. Condition. See this. Proof. The lines are parallel. That means we take the diagram. This line will take it as L1 and this line will take it as L2. This is theta 1, this is theta 2. This is on x-axis and this is y. And here, proof, consider two lines L1 and L2 with what we are having with inclinations theta 1 and theta 2 respectively. Yes or no? Then by the definition, slope of a line L1 equals to what we can write tan theta 1. This will take it as, because two slopes are there, first slope I will take it as m1 tan theta 1 and slope of a line L2 equals to tan theta 2 and this will take it as m2 equals to tan theta 2. What we have to prove? Their slopes are equal. Their slopes are equal where means because here the lines since there is a relation, these two lines are the lines L1 and L2 cuts x-axis acts as transversal. What is meant by transversal? Transversal means corresponding angles are equal. What is transversal? Corresponding angles are equal. What are the corresponding angles we are having? Theta 1, theta 2. Therefore, with this is getting number. Consider two lines with inclination theta 1, theta 2. Slope of a line L1 we have taken as m1 theta tan theta 1. Slope of a line m2 we have taken as tan theta. Therefore, with this we are getting what we are getting about theta 1 equals to theta 2. Corresponding angles are equal because they are getting transversal. Now apply tan on both sides. What we are getting? Tan theta 1 equals to tan theta. Tan theta 1 what we have taken? Slope m1. Tan theta 2 what we have taken? Slope m2. Therefore m1 equals to m2. Therefore their slopes are equal when the lines are parallel. When two lines are parallel, what the condition we can take now there? Their slopes are equal. Okay, ma? M1 equals to M2. Children, you can raise your doubts on the running topic, what we have been done straight lines. Chart box. One of the student asking what is meant by locus. So many examples we can take there. Locus is nothing but it is a path, simple definition, which satisfies the geometrical conditions. For example, we are having a locus point P. Okay, we are having a locus point P. This is the, we take, what is the we have taken here? It is the, we take example, what example we have taken, because you don't know about what is meant by circle, remaining curves we don't know there. Here we are taking the example of line only there. We are having AB as line segment and we are having locus point P. Here geometrical condition what we are having, this P is always distance fixed from P to A and P to B. It is always fixed to the 2 points with a fixed distance. This we call it as locus of a point satisfying the geometrical condition. Any geometrical condition, we will have a circle, parabola, ellipse. We will come to know there. The locus of a point means is nothing but which it is a path. What is the path we are having here? There traveling from P to B, P to A. What is the path condition here? Geometrical condition, fixed distance. Distance is always equal from a fixed points A and B. Fixed distance from P to A and P to B. This is the geometrical condition. Therefore, we can write PA equals to PB. We can write PA equals to PB. We are preferring tan because here we have been derived inclination theta. When you know the inclination theta and positive direction, we have taken m equals to tan theta. Why? Because initially coordinate system, it is 0 x-axis, y-axis, x dash, y dash. It rotates 0 to 360, but we are taking m is equal to tan theta from only x-axis. What is the condition? 0 less than or equals to theta less than 180 degrees. Okay, ma? Positive direction. If you see that whenever angle, if you are making, this is the right angle triangle or not? This is the right angle triangle. If you are taking simple logic here, we have to take by y-axis y, x-axis always. We should take it as y by x. Whenever we have to make the angle, first of all, in the right angle triangle, we have to start by the ratio of y by x. When you will get y by x, tan theta equals to y by x. Therefore, we have taken slope as m equal to tan theta. Or otherwise, slope of the x-axis. Here, other than tan, these angles will not come. If you see angle-wise, slope of x-axis is initially 0. Yes or no? Therefore, when you are taking m is equal to tan theta, if theta equal to 0 degrees, m we are getting tan 0 means 0. Only tan will get 0 there. Getting it? Sin 0 will get 0, but it is not, sin will not get 90 means not defined. Therefore, one case it will obey, one case it fails. Therefore, tan only, other than any other trigonometry function, we can't take for the slope. If you see the y, it is not defined. Okay, therefore, theta is 90 degrees we will take because it is perpendicular. We are getting m equals to tan 90 degrees means it is not defined. Therefore, when you take tan only on x-axis, we will get 0 as well as not defined. Or otherwise, simply whenever if you want to make the angle in the right angle triangle, always we have to prefer variable y divided by variable x. Simple logic. Children are asking which theorem is important. Only parallel condition of parallel. We have seen the theorem 2. Theorem 2. Yes, if two lines are parallel, we have proved what their slopes are equal. This theorem is exam point of view important. That what we have proved m equals to y2 minus y1 by x2 minus x1. It is not required for exam point of view, but we require only for. And one more thing, the children are asking what is meant by non-vertical line. Here, if you see, there are three types of lines in straight lines. This is what horizontal, we call it as x-axis, and this is vertical line, we call it as y-axis. Other than these two, we are only having inclined. If you see, slope is having other name. It is gradient. Gradient is nothing but inclined line of roads. That means when you travel, the road will not always be like this. Somewhere we will get like this. Yes or no? It is inclined line of a roads or railway tracks. Or railway application of straight lines, we should go there. Why we have to take the non-vertical line? Why we have to take non-vertical line means it is the other than horizontal vertical, this non-vertical line is called as inclined line. This inclined line is nothing but inclined line of roads or railways. When the track is moving, the track will not be like this. It will move somewhat slope. Okay, ma? For that purpose, to prove the slope or increasing or decreasing things, when we want to solve, we have to solve one non-vertical line. That is named as nothing but somewhat slope we are getting there. When non-vertical line, then only we can indicate angle. Yes or no? If you take the triangle, these are non-vertical lines. Angle, angle, angle. When we are having only perpendicular, this here we can represent the angle. That's it. Therefore, inclined lines represent for inclinations.